Here's the last part of section 4.3 talking about properties of logarithms, and since logarithms and exponents are inverse to one another, the properties of exponents are kind of follow the same rules, or properties of logarithms kind of follow the same rules as exponent properties. So exponent properties are like when I have the same base. When I multiply by the same base, I add exponents. Okay, well that's the same thing kind of as a logarithm. When I have taking the log with some base, and I am taking those logs with the same base and I'm adding them. So if I'm adding two logs with the same base, then I can go ahead and multiply what I'm taking the log of. So that's equal to the log with the same base, and then I just multiply the 3 and the 5. So log of 15. Or I can say, log of 15. So if I make it in general, say log with some base of, say, x plus log of that same base. It has to be the same base of y, then I'll get log that same base a of x times y. So that's kind of the general rule of the product property. And then another exponent rule is when I divide by the same base, then I subtract exponents, right? Top minus the bottom. Top is always comes first, right? So the 3 exponents on top, so that 3 exponents on top when I subtract. Okay, so same is true kind of with the logarithms, just a little bit different, right? So if I have 2 logs, or if I'll go kind of the other way. If I have a log of some base, and I am, say, dividing them, so I'm taking the log of a quotient, right? Taking the log of a division thing here. Oh, well, I guess I could divide those, right? So maybe I put like 13 or something. Then I can rewrite that log as 2 separate logs that are being subtracted. And then the top comes first, just like on the exponent, the top comes first. But just make sure you have that same base. Okay? And so I can make it more general, just erasing the 15 and putting x, and erasing the 13 and putting y. So if I'm taking the log of a quotient of a fraction, then I can separate that into the difference of the logs, with the log of the top minus the log of the bottom. Okay? And then power property is when I have a base raised to an exponent and then I raise that to another exponent, I multiply 3 times 5. Same is kind of true on a logarithm. Okay? If I have a log of some base of 3 raised to 5, well then I don't multiply 3 times 5. I actually multiply the exponent times the log. So the exponent is being multiplied by that log with that same base. So like that. More general, x raised to y. The log with base a of x raised to y is y times the log with base a of x. Okay, so those are the logarithm properties. Those 3 right there. And there's 2 things that you can do with them. You can expand them, right? We can start on the left and make it bigger, or you can condense them, start on the right side and make them smaller. So here's an example of expanding, so we want to expand these. So here is the power property, because I'm multiplying. This second one is the power property, because I'm multiplying. But also that square root of x, I can rewrite as x to the 1/2, so I am using the power property, sorry. And then as the product. So the product deals with this multiplication. The power deals with that exponent. So this top one is not the power. It is the product property. Okay, this bottom one, I have a division, right? I have a fraction, so that's the quotient. Average spell quotient. And then also, I have m times n times q and p squared times t to the fourth. So that means I also have the product. And then I also have an exponent on both the p and the t, so also the power. So it's all 3 on this one. Okay, so let's go ahead and expand these. So we keep the log with the same base as we expand it, so we want to create more than one log. So since I'm multiplying, I just take the log of those factors with the same base. So the same base and then just the log of each of those factors, and we add those logs. Okay. Same thing on the second one. We expand it. It's multiplication, so that means we're going to be adding the logs. We just keep the base the same. And then what the factors are, right? Root x and y, those are my factors. Those are what we're going to be taking the logs of. Okay. Now I can rewrite square root x, x to the 1/2. And then I can rewrite that 1/2. Now it's a power property, right? So now the power property comes in. And now I need to multiply my exponent by the log. Remember, keep those bases the same. Okay, last one. We want to do the quotient property first. Log base A, the top, minus the log of the bottom with that same base. Okay. Now I have multiplication inside my log. So whenever you do this, you can do one step and then look, is there any more properties that I can use? Is there multiplication going on? Is there exponents going on? Is there a fraction going on? Always ask those questions when you're using these properties. So here I have multiplication going on, right? And over here, so I can separate this. Log base A of m plus log base A of n plus log base A of q. And then I'm subtracting this whole thing, right? So I'm subtracting this whole thing. So that means I'm subtracting log base A of p squared plus log base A of t to the fourth. Now what you can do on these two is basically whatever's in the denominator, I'm going to be subtracting that log. Okay, so when I expand it to the log of p squared and log of p or t to the fourth, those are both going to be negative logs, okay, because they're in the denominator. All logs on top will be positive. We'll be adding logs. Okay, now we can expand this again because here we have exponents. So we can take the exponent and multiply it by the log. I'll just keep the parentheses so far. But I know since they're in the denominator, they are going to be both negative. Now I could go ahead and distribute that negative. If you kept it inside the parentheses, that'd be fine. So log A of m plus log A of n plus log A of q. Make sure those parentheses, you can distribute the negative. Negative 2 log with base A of p. And now this becomes negative 4 log base A of t. And so that's all done. All right, I got some homework problems for you to work on. Oh wait, let's do some condensing. Sorry. Condensing is turning into one single log, and usually our coefficient in front needs to be 1, so we need to use that power property if we have something times by the log. So we want to turn this into one log. Okay, so I'll do these kind of step by step, and then in the actual problems I'll just probably just put it into one single log. without doing the steps. Okay, so here I'm adding. So that means that these two, what I'm taking the logs of, because those two logs are positive, they're going to be on top. Because this log is negative, it's going to be on the denominator. Okay, so I could multiply these first, keep the same base, and when I add two logs, I'm multiplying what I'm taking the logs of. Okay. Now, because I'm subtracting these two logs, that means I'm going to have a quotient, right? Keep the log with that same base. And now what I'm taking the logs of is now going to be divided by, with the first on top and the second on bottom. So there's my finished answer of 1 log. Now this second one, what you want to do here is we know we have addition, so we know we're going to multiply these, but I need to take care of this power property first. Okay, so I need to move that 2 as an exponent because right now it's being multiplied by the log, so I use my power property, move it as an exponent. So x plus 1 quantity squared and log base A of 3x plus 2. And so you might have problems like this where you're asked to solve problems like this where you have an equal sign. Most likely you probably want to have that squared there. So now we're adding these two logs, so now we're multiplying what we're taking the log of. Keep the log of that same base. And here, since that's squared, we don't need to FOIL that out. We're just going to multiply it, so we can put these parentheses right next to each other. So if this was actual equation, you probably wouldn't have that squared. So then you would just probably FOIL, let me change colors. You probably would just FOIL the x plus 1 and the 3x plus 2. So then you would have a quadratic. And you solve logarithms by switching to exponential. So you would switch to exponential, and then you probably would solve some sort of quadratic equation for x. Okay, so that's how you go ahead and condense, make it smaller into one single log. Okay, now we can go ahead and work on these problems: 63, 65, 69, 73, 75, 79, 81, 85, and 87. 85 and 87 are a little bit different, where we actually use what a log is actually equal to, kind of the approximate answer for that, and then use that to find kind of by substitution a little bit. Okay, so we're going to expand these logs. Okay, so whatever's on top, look what's on top. Is it what's happening with these factors? They're being multiplied, right? So that means I'm going to have an addition there. However many factors you have, probably that's how many logs you're going to have. So I have a 6, an x, and a y. So that means I'm going to have three different logs with base 2. Okay, and it's going to be a 6, an x, and a y. Now the question is, am I adding these logs or subtracting? Well, since I have a quotient, that means I'm going to be subtracting. But these two, 6 and x, are together on top, and if they're in the numerator, that means I'm going to be adding those two logs. So I'm going to add those two logs, and then whatever's in the denominator, that's going to be subtracting. So then I'm going to subtract this log. And so there's your answer. Okay, 65. Okay, here we're multiplying 5 times square root 7. So that's a multiplication there. Okay, but also this division right here, so that means there's going to be subtraction. And then how many terms do I have? The 5, the root 7, and the 3. So that's 3 terms, so that means I'm going to have 3 logs with that same base of 5. And now I have 5, I have square root 7, and I have 3. Okay. Now, am I going to be adding, subtracting, what? So since I'm multiplying 5 times 7, that means I'm going to be adding those two logs. And then since I'm dividing by 3, that's going to be a subtraction of that log. Now I can simplify this one step further because I actually know the answer to this. This log of 5, the log with base 5 of 5, 5 raised to what is 5? That'd be 1. So this answer would be 1 plus log 5 root 7 minus log base 5 of 3. Now you could take that root 7 and rewrite that as a fraction, as an exponent. So you could rewrite that as 1/2 7. And now it's a 1/2. So now we could use the power property and move that 1/2 move that exponent and being multiplied by the log. So probably the final answer in the back of the book is probably this. 1 plus a half times the log with base 5 of 7 minus the log of base 5 of 3. Okay. 69. This square root, this 5 times r raised to 3 divided by 2 raised to 5. Okay, so I have multiplication here and I have division. Okay, and then how many factors do I have? I have 5 root 3 and 2 root 5, right? So there's 3. So there's going to be 3 logs, but because they're inside this square root, that's a power property, right? Because I can rewrite square root as a half power. So when I expand, I need to take care of my power properties first. So this is all raised to the 1/2, so I'm going to move that 1/2 out front first. And I probably want to put parentheses around this log with base m. Because basically what that means is every log, you could distribute that 1/2. Every log is going to be, because every, well, I'll do it 2 different ways here. Let's keep going. All right, and now I can separate this. I have, well, let's do red. I have multiplication, and then I have division, right? And then I have 3. So that 1/2, I'm going to have 3 logs, 1 of 5, 1 of root 3. I'm going to need more room. 1 of root 3 and 1 of log of 2 to the 5th. Okay, so there's adjusted. So we have 1/2 times the log of m base m of 5 log base m of 5 cubed and log base m of 2 to the 5th. So here we're multiplying, right? R times r cubed times 5, so that means a plus between them. And then here on the bottom we're dividing by 2 to the 5th, so that means we're subtracting that one. And now we can go ahead and do our power properties, right? Because we have an exponent of 3 and an exponent of 5 on those 2 different logs. So we get 1/2 log base m of 5 plus 3 times log base m of r minus 5 times log base m of 2. Then you could distribute the 1/2 to all of those, or you can leave it out front. That's okay. So what you could do is you could separate this from the very beginning. Separate the square root of 5 times the square root of r cubed over the square root of 2 to the 5th. So then you can see that that's the same as distributing this 1/2 to all 3 of those logs, right? Because they're each being raised to the 1/2 power. Okay. And then so you would, yeah. Anyway, would be fine. Okay. So let's move on to 73. Expanding. So how many different factors do I have? 1, 2, 3, 4. So that means I'm going to have 4 logs. Okay, with the same base of 3. And now what are my variables in there? I have x, I have y, I have w, and I have z. Now what powers are they being raised to? Well, x is a square rooted, so that's to the 1/2, so we can put that 1/2 out in front of that log of x. And then y is being cube rooted, so that's 1/3, so I can put 1/3 in front of that log of y. W is being squared, so I can put a 2 out in front of the log of w, and then z is also being raised to the 1/2, so I can put a 1/2 in front of the log of z. Now, which one's going to be adding, which one's going to be subtracting, and so on. So because I'm multiplying this log here between the x and the y, that's going to be addition. And because so there's 2 things you can do here. This on the bottom is multiplication, so I could put a plus here, but then I am dividing this bottom half, so I would put that in parentheses here. If I put a plus sign here, then I would put that in parentheses. Or you could think, okay, because I am dividing here, I have a quotient. Whatever's in the denominator is subtraction. So W's in the denominator, so that is subtraction. And Z is also in the bottom, so that is subtraction. So that's my final answer there. Okay, or you could leave those negatives undistributed, just make sure you have parentheses. Okay, 75 we're condensing to 1 log. So we're making it into 1 log. So 1 log with 1 base, so base A. Now whatever we're adding is going to be in the numerator, and whatever we're subtracting is going to be in the denominator. So these 2 logs, we are adding these 2 logs. So what we're taking the log of is going to be in the numerator, and it's going to be multiplied. And then whatever we subtract, that's going to be in the denominator. So there's my answer. Here's a little bit trickier. I'm combining, I want 1 single log with that base B. Okay. Now here I have several different things kind of going on because I have powers and I have something being multiplied by the log. So you can look at all the letters, but I think they want these kind of all joined together and reduced and everything. So these 2 are already together, so they're going to stay together, right? These 2 are already together, x squared and y are already together. So they didn't even separate those for us. So they kind of helped us out already kind of starting this process. But we noticed that there is subtraction right here, so that means we are going to have a fraction. That means what I'm taking the log of here on the left would be on the numerator, right? Whatever comes first is going to go on top, and whatever comes after the negative is going to go on bottom. But because we have this 1/3 and this 3/4, it kind of messes something up, but not too bad. I know I'm going to have an x and a y up top and an x and y at bottom, but just what are their exponents going to be is the case. So first we can rework the power property, right? We can take this 1/3 and raise it to what I'm taking the log of, so I need to raise it to that. So let's rewrite that. Log base B of x to the 4th, y to the 5th. Those are both being raised to the 1/3. And then we're subtracting. Now I can raise this 3/4 to what I'm taking the log of. So log base B x squared y raised to the 3/4. Now I'm kind of mixing it and mix some properties here because I want to create 1 single log, but I want my x's and y's. I just want 1 single x and 1 single y, right? So in order to do that, well, I could combine it right here. There is subtraction here, so we could just write it as 1 single log. The first is always on top. The positive log's on top. And the negative log is always on bottom. Okay, so we can do that. But here we want 1 single x and 1 single y. So we can use our properties of exponents that say, hey, when I raise a product to a power, I distribute that product to the exponents. So this becomes log base B of x to the 4/3 y, and there's probably different ways you can go about this too. And then 5/3 over, now I can distribute the 3/4 to the 2 and to the 1 on the y. So x to the 3/2, because the 2 and the 4 cancel out, and then y to the 3/4. Then I can use my properties of exponents again and say when I divide by the same base, I subtract my exponents. So log base B. And now I'm taking 4/3 and minusing 4/3, and I'm minusing 3/2, right? So I have to common denominators. So this is 8/6, and this is 9/6. Correct? Yes. And then I can subtract those, so I get -1/6. So this would be x to the -1/6. And now I can do my y's. My y's is taking 5/3, so 5/3, and subtracting 3/4, right? Because when I have the same base, I subtract my exponents. So now this one needs a 4 4, so that's 20 twelfths. And this one I need a 3 and a 3, so 20 twelfths minus 9 twelfths is positive 11 twelfths. So positive 11 twelfths. So y to the positive 11 twelfths. So now I just have one single x and one single y, and that's what they wanted you to get. Okay, a couple more. Excuse me. Okay, so we can do our power property because we're multiplying the number times log, so that's log base a of z plus 1 squared. Just kind of like your example. Is it the same as your example? Not quite, it just has an x in there, right? That's the only difference, I think. And now we're adding two logs, so that means, oops, I switched x because I said it. So now we're multiplying what we take the logs of. Okay, now 85 and 87 is different. We're using this fact that we're going to log base 10 of 2 is equal to 3.010. It's probably approximation there. And then log base 10 of 3 is 4.17. Now we want to find out what is log base 10 of 6? Well, how do I get 2 and 6? Or how do I get 2 and 3 to 6? Well, you multiply them, right? So that means this would be log base 10 of 2 times 3. And isn't that the same as log base 10 of 2 plus log base 10 of 3? So then can I add these answers? Can I just add them? Because that's what I'm doing. I'm adding this log, which is 0.3010, and adding this log, which is 0.4771. So can't we add those? And we get log base 10 of 6 is equal to 0.7781. And so there's my answer. Okay, next one, same kind of thing. Now here I'm taking 3 over 2. Well, log base 10 of 3 over 2, since I'm dividing, and since I have a quotient here, that means I would be subtracting my logs, my top minus my bottom. And now, so I'd be subtracting these numbers. So I'd be taking 0.3010 and then subtracting, well, let's do it underneath, 0.4771. And then we can go ahead and subtract these. 0, 1, we get 9. Can't take it away. Take it away from there. 2, so on. I'm just probably going to eventually... Actually, probably should just add to what that is, but that's okay. Or I should just use a calculator because sometimes it's a little faster, right? Yeah. So it would probably help if I actually put these in the right format because I can't do that. So let's rewrite them the right way because it's log of 3, which is 0.4771, and minusing log of 2, which is 0.3010. Now I'm going to have an easier time actually doing the algorithm of subtraction, right? There we go. A lot easier. So there is log base 10 of what? 3/2 is equal to 0.1761. It's probably approximation. Okay, all done.